Friends, welcome to my YouTube channel. Dhanesh here at another interesting session on machine learning. In this video, I am going to discuss about bivariant analysis. It's part of EDA. Let's start. This is the 10th video on feature engineering. Here I am going to discuss about bivariant analysis, and it is it's part of exploratory data analysis, EDA. You are familiar with EDA. It is exploratory data analysis. Let's look into the goals of feature engineering. After that, we will get into the bivariant analysis. In feature engineering, we prepare the proper input data set. That's what we do. Here we need to improve the performance of machine learning and machine learning model as well. So what are all the steps we can do to improve the performance of machine learning model? In feature engineering, it's simple. We convert data into features. That's what we do as part of feature engineering. See, this is really important. These are all the steps to prepare. These are all the steps coming under feature engineering. What are all the steps to prepare data to build a good machine learning model? The philosophy of feature engineering is the quality of your input decides the quality of your output. Below are the steps involved. So this is as your input, the quality of your input increases, the output also increases. So there is a lot of importance in feature engineering. When the 80% of the work of a data scientist is in feature engineering. So let's get into the different steps in feature engineering. Variable identification, univariate analysis. These two steps we already discussed. You have the videos in the playlist under feature engineering and in statistics as well. In this video, I am going to discuss about bivariant analysis, missing values treatment. This also you have the videos available in the playlist. Outlier treatment, the videos are available under feature engineering. So variable transformation and variable creation, I need to prepare the videos for variable transformation and variable creation. Anyway, so you need to understand these are all the steps coming under feature engineering. Let me talk about what is exploratory data analysis, EDA. EDA is a set of statistical approaches to explore and understand data. That's what as part of EDA we do. As part of EDA, we do a set of statistical approaches to explore and understand data. It is beyond hypothesis testing and experimentation. There are mainly three kinds of analysis done in EDA, namely univariate analysis. We already discussed. In this video, I am going to discuss about bivariant analysis. The next one is multivariate analysis. These are all the three steps we usually follow as part of exploratory data analysis. What is bivariate analysis? See, bivariant, bi means it's a Greek word, bi means it's two. Univariant, uni means one. We also, mono is also one. So bivariant means this type of data involves two different variables. In univariate analysis, we have only one variable. For example, the height of the students in a class. Only one variable. Weight of the students in a class. Only one variable. It is univariate analysis is enough. But in bivariant analysis, there are two variables will come into picture. Bivariant analysis finds out the relationship between two variables. See, it's like a regression problem. See, the relationship, when you talk about the relationship between two variables, it's a relationship means it's a regression problem. Regression, you need to understand. See, univariate analysis, we won't discuss any relationship because there is only one variable. But when we talk about bivariant analysis, the relationship between variables, that's a regression problem. Relationship means as one variable increases, the another variable can also increase. That is, we call them as they are directly proportional. They are directly proportional. We will tell those variables are directly proportional. For example, as volume increases, as temperature increases, volume increases. That means temperature is directly proportional to volume. Another example I can tell, as pressure increases, volume decrease. That means they are inversely proportional. See, these variables are interrelated. As pressure increases, volume decreases. They are inversely proportional. See, this type of relationship only we are analyzing. This relationship can be linear, sometimes they can be linear, or sometimes they can be non-linear as well. You need to understand. So this relationship can be linear or non-linear. See, bivariant analysis finds out the relationship between two variables. We can perform bivariant analysis for any combination of categorical and continuous variables. See, in the last video also we discussed there are two types of variables. One is the categorical variable and another one is the continuous variable. A simple example I can give you, then you will understand. Continuous variable means height of the student, it is continuous. Weight of the students, or it is continuous. Categorical variable means I am telling gender, so it can be male or female, two categories. That is a categorical variable. Then after the exam you will get the result. The result can be pass or fail, two categories. You will be coming under any one of the categories. So such variables we call it as the categorical variables. So this continuous variable, see, when we discuss about the bivariant analysis, there should be two variables, that both the variables can be continuous variables, both the variables can be sorry, categorical variables. One variable can be categorical and another one can be continuous. See, in these cases the treatments are different. You need to understand, when the two variables are, both the variables are categorical, so how we will do the bivariant analysis? So all these things, it's different. We will be discussing in the coming videos these aspects. So the combination can be, as discussed, categorical and categorical, categorical and continuous, and continuous and continuous. Like this, the combination can be different. I think you understood this. So different methods are used to tackle these combinations during analysis process. Now, next I am giving you an example for bivariant analysis. I already given you like pressure and volume, then volume and temperature. Now another example of bivariant data can be temperature and ice cream sales. If the temperature is very less, if it is very cold, the ice cream sales will be less. So they are linearly related. We can tell they are directly proportional. Here the temperature in Celsius, it is 21, 26, 36, 44, 21 degrees Celsius. At that time the ice cream sales is 2200. When the temperature is 26 degrees Celsius, the ice cream sales increased to 2600. When the temperature becomes 36 degrees Celsius, it again increased to 5500. When the temperature becomes 44 degrees Celsius, it reaches 7900, the ice cream sales. So they are linearly related. They are directly proportional. These two variables are directly proportional. We can tell these two variables are categorical variables. These two variables are continuous variables. Both temperature and ice cream sales are continuous variables, as we discussed. See, example of bivariant analysis, as we discussed, the temperature and ice cream sales are two variables, and temperature as increases, they are directly proportional. We discussed about that. Thus bivariant data analysis involves comparisons, relationships, causes and explanations, how they are are related, how we can compare with between these two variables. See, in the previous thing, see, this is the case. If 21 2200, see 26 2600, then another day, the next day, the temperature is 35 degrees Celsius, or we can take it as 32 degrees Celsius. What should be the ice cream sale? What should be the number in ice? This is the prediction we need to do. So this type of analysis, these are all regression problems, right? So this type of analysis are coming under bivariant analysis, right? So you understood this. So these variables are, see how we predict this. See, this bivariant data analysis involves comparisons, relationships, and causes and explanations. What we do here, so how do we predict this? These variables are often plotted on x and y axis on the graph for better understanding, and we can predict it. For example, here we have taken the temperature. Here we have taken it as 10, 20, 30, 40, 50, 60. Then ice cream sales, it is like it's starting from 2000, right? Okay, so we can take the ice cream sales like this. Here it is 2000, here it is 4000, here it is 6000, here it is 7000. Like this we can take the ice cream sales in the y axis. Then you can plot a graph when the temperature is it's given like 20, it is 2200, so it will come 21, right? 21 degrees Celsius, so the point will come here. Then the next point you can plot, it is 26, 36, 5500. So when it is 36, it is 5500, means here 36, it will somewhere here. So you can draw the graph between these two, and you can predict if it is another temperature 35, you will draw a line like this, and you can predict the sales. So this is what we do in the bivariant analysis. But when the different cases, like for example, one categorical variable and another one continuous variable, and both of them continuous variables, both of them categorical variables, what we will do how we will do the bivariant analysis. So here that thing we will do, we will do it in the next video. See, here both the variables are continuous variables, so we could do with a graph, and we could do that. So when if both the variables are categorical variables and one variable is continuous and another one is categorical, how we will solve the problems. So those type of methods we will be discussing in the next video. So this is about the bivariant analysis. Thanks for watching. Please like, share, and subscribe. Thanks a lot.